So please, when you have got a question from your past papers in the past papers, just shout it after I finish solving this one, okay? So square root of x is equal to square root of 2x minus 1 plus 2. So I think when we are learning this topic, we use this question as an example. So we are saying when you are solving absolute value, I mean radical equations, make sure that one root is on an opposite side and then the other root is also on the other side. At least one root should be with a number instead of two roots together. Now this root looks a bit of complex, so I want it to be alone. Okay, so I'm going to take 2 this side. So I'm going to have square root of x minus 2, and that is going to be equal to square root of 2x minus 1. Now at this point you have to square both sides of the equation. So this side we are going to square, and then please, this side don't square individual terms. Don't say square root of x alone squared and then 2 squared. No, on the side of the equation, as long as you have got all the terms on the same side of the equal sign, put them in brackets and then you square. Okay, so this is going to give us, now to square something that is given like square root of x minus 2, get the first one, you square it, that is going to be the square root of x squared, it will just be x, right? And then get the power 2 multiplied by the square root of x, also multiplied by negative 2. So 2 times negative 2, that's negative 4. Negative 4 times square root of x, that will be negative 4 square root of x. And then get the negative 2, also square it. That is going to give you a positive 4. If you want, write square root of x minus 2. Again, square root of x minus 2, start crossing and multiplying. And this is going to be equal to, this side, the square and the square root, they will cancel. So that is going to be 2x minus 1. At this point, please, anything that doesn't have a root, take them the other side of the equation. I just want to remain with the roots, just this. So I'm going to have negative 4 square root of x, and that is equal to, if I take this x the other side of the equation, we're going to have 2x minus x. That is going to just be x. Like this, x will become negative. So it will be 2x minus x, it becomes x. And then we'll take this for the other side, it becomes negative, right? So it will be negative 1 minus that 4, that will be negative 5. And then from this point, to remain with x, you are going to square again, right? So I'm going to again square this side and also square this side. Again, don't square these individually. I hope that is okay. So negative 4 squared, that is z positive 16. And then square root of x squared, that is just x. And that is going to be equal to x squared. You get the first time you square it, so that will be x squared. And then 2 multiplied by 5 multiplied by x, that is going to be negative 10x. And then get the 5, you square it, that is going to be positive 25. If you want, write x minus 5 2 times, and then you start crossing and multiplying like that. And then I'm going to take everything to the same side. So I'll take the 16x also the other side, so there will be a 0 here, and that is going to be equal to x squared. 16x goes the other side, it will be negative 10x minus 16x. That is going to be negative 26x, and then plus 25. This I can also write it as x squared minus 26x plus 25 is equal to 0. So here we can see the product of this function. You get a number in front of x here, you multiply with this constant, so the product is 25, and then the sum is that constant that has got x, which is the negative 26, I mean the coefficient of x. So what two numbers can you multiply to get 25? When you add them, you get negative 1. Anyone who can help us with this one? Isaac, what two numbers can you multiply? You get 25, you add them, you get negative 26. Or do we have anyone else who can give us those two numbers? And what I know about mathematics is that it sticks in your brain. When you get to speak, it more sticks. Trust me, these are errors you, if you take advantage of this thinking they are too simple, you can make a mistake in the test. Okay, like you can forget. Anyone to help?
I think no, -1 and 25.
Okay, so both are supposed to be negative, right? Negative 25 and negative 1. If you multiply, you're going to get a positive 25. If you add them, you're going to get a negative 26. So this is going to be x negative 1, x negative 25 is equal to 0. Mean that x is equal to 1 or x is equal to 25. Now, friends, for radical equations, you need to check your solutions. Okay? Please always do. So when x is equal to 1, let's check. Where there is x here, let's put 1. Square root of 1, we know that is 1. And that is supposed to be equal to, put 1 here. Okay, put 1 there. So it will be 2 times 1, which is a 2. Minus 1, which is a 1, right? Square root of 1 is a 1. Plus 2, that is a 3. Now, is 1 equal to 3? We know this is not true, right? 1 is not equal to 3. So that means this is not correct. And then we go to the next one. So meaning that 1 is not a solution. And then the other factor that you found is x is equal to 25. Also test it. Put here where there is x, put 25. Square root of 25 is a 5, right? So that is going to be 5. And that is going to be equal to, put here 25 again. 2 times 25 is 50. 50 minus 1 is 49. Square root of 49 is a 7. 7 plus 2 is a 9. Is 5 equal to 9? No. So we've seen that both answers that we have found are not solutions. Therefore, the solution set to this equation is an empty set. You can either write it like that or you can write something like this. Curly brackets. Don't put anything. Don't even put a 0. Just write them like this. So this means that the solution set is an empty set even if these are values we have found, but they are not solutions to this equation. Right. That is how you get to answer these questions. Okay, so we're going to go to the next one. So since we are doing all the topics from sets to functions, I'm going to be picking random questions just from past papers. Okay, so the next one which I'm able to find, we have got here, I've got square root. Let me not use this radical again. Let me use this one. Okay, here we have got 2x minus 6 divided by x plus 3 is less than negative x minus 2. Okay, there. So how do you get to solve this one? Now, since this is a rational function, why is it rational? You can see the denominator has got a letter. For a rational function, you are not allowed to cross multiply. So immediately you do this, and then you start doing this times that, this times this, you've automatically gotten it wrong. Unless if this was just a number in the denominator, you could cross multiply. Okay, those are rational functions. So since this one is a rational function, we can't cross multiply. What are we going to do? I'm going to get these terms, take them the other side of the equation. That is going to be 2x minus 6 divided by x plus 3. This negative x goes the other side, becomes positive x. The negative 2 goes the other side, becomes positive 2. And this is going to be less than 0. We are going to have a 0 remaining this side. From here, I can also now say this is over 1. I now need to make this as a single fraction. So what I'll do, I'll multiply this, which is on top of the first fraction, with what is down the second fraction. That is going to be 2x minus 6. And then I'll multiply what is on down the first fraction with what is on top of the second fraction. So I'll start like this. X times x, that is going to be positive x squared. X times 3, that is going to be positive 3x. and then we go to 2 times x, that is going to be positive 2x, and then 2 times the 3, that is going to be a 6. In the denominator, also multiply the x plus 3 with the 1, that will just give us x plus 3, and this is going to be less than 0. Okay, now add like terms. So I'll start with the x squared. We are going to have 2x plus 3x, that is 5x, plus 2x, that is 7x, and then we have got a plus 6 there, divided by x plus 3, that is going to be less than 0. Now what is on top, we need to factorize it. So the product, for the one on top, what is going to be the product? Anyone? What is going to be the product of this equation here, or that
No,
fact?
no,
Okay, the product is a 6, isn't it? You get a number in front of x squared, you multiply by the constant, that's the product. So that's 6, and then the sum is that number in front of x, which is a 7. So you want two numbers which you can multiply to get 6. If you add them, you get 7. Okay, 6 and 1, right. So that means that this is going to become x plus 1, x plus 6 divided by x plus 3 is less than 0. So when you reach here, this is a point where people get lost now. They start doing other things. Equate everything you're able to see to 0. Equate x plus 1 to 0. We're going to find that x is equal to negative 1. Equate x plus 6 to 0. We're going to find that x is equal to negative 6. Equate also the x plus 3 to 0. We are going to find that x is equal to negative 3. When you find these values, please, when you follow this, you never go wrong. You will never go wrong. And I'm just writing those factors which I was equating to 0. Okay, the first factor which I equated to 0 was x plus 1. Friends, I've left a space here and I've done it intentionally because I'm supposed to put a sign here. Now, imagine you are writing, you write a table and then you write x plus 1 here. Where are you going to put a sign? So, x plus 1. The next factor which I equated to 0 is x plus 6. And then the next one I equated to 0 is x plus 3. Okay, the values which we have found negative 6, negative 3, negative 1. Now you are writing this in increasing order, starting with the smallest, ending with the biggest. This is a number line, so if you also write them in another way, you are going to get it wrong. Okay, I hope that is okay. Now from here, when I equated x plus 1 to 0, I found a negative 1. A negative 1. This is the one here. Mean that negative 1 is going to be the demarcation of signs for this factor. What happens if I get values of x greater than negative 1, like a negative 2? I put here. Sorry, negative 2 is not greater than 1, like a 0. Okay, 0 is greater than 1. Or like a positive 1, I put here. 0 plus 1 or 1 plus 1 is going to give us a positive value. Remember, I've said negative 1 is the demarcation of sign, meaning that immediately I cross negative 1, all the signs this side are going to be negative. And when I equated x plus 6 to 0, I found negative 6. Meaning that for that factor, negative 6 is going to be the demarcation of signs. What happens if I get any value above negative 6, like a negative 5, I put here. Negative 5 is bigger than negative 6. So negative 5 plus 6, it is positive 1. Meaning we are going to get positive as long as we use anything above negative 6. But when we just cross the negative 6, it gives us a negative. X plus 3 equated to 0, found a negative 3. So negative 3 is the demarcation of sign for that factor. What happens if I use values of x greater than negative 3, like a negative 2 or a 1? I put here. It is going to give us a positive value. Immediately across is going to be negative. Now remember, these factors are dividing. Okay, they are dividing. So I'm interested in the quotient of signs. Quotient. So negative, negative, negative. When you divide three negatives or multiply three negatives, you're going to get a negative. Negative, positive, negative, it will be positive. Positive, negative, negative, positive, positive, it will be negative. Positive, 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 is positive. Now remember, for this equation, we're interested where the values of x are less than 0, and values which are less than 0 are negatives. So it means it's from here up to here, and then from here going in this direction. That's what I'm saying. So all you look at is the quotient. The quotient, you look at where the quotient is less than 0 or where the quotient is negative. Now you can see I'm putting circles, I'm not shading the circles. Why? Because this is just less than 0. Okay, meaning that we are not going to include 0. So meaning that the solution set to this equation, to this inequality, the solution set, the smallest value here, you can see where the arrow is going, it is going towards negative infinity. So I'm going to say negative infinity up to where? It is going to come and pause at negative 6. Okay, you always write the smallest number when you're writing set intervals. So to negative 6, remember we're not including this. And then you say union from negative 3 up to negative 1. So this is the solution set to this inequality. Now if it was less than or equal to, you would have shaded these. Okay, you would have shaded these values here like that. It is expected that you shade all of them. But look, the factor that is in the denominator, it can't be equal to 0. When we got x plus 3 to 0, we found negative 3. Meaning that negative 3, even if the question itself is saying less than or equal to, we can't be equal to negative 3. We can't be equal to negative 3. Okay, so meaning that even if it's like that, I will not shade at negative 3, but I'll shade at other values. So meaning that the solution set would have been from negative infinity up to negative 6. Negative 6 would have put a closed interval bracket, and then union negative 3 open interval bracket, and then negative 1 closed. Now the badness is that if you put a wrong bracket where you're not supposed to put it, you're going to lose marks. Okay, I hope you are going to be able to follow this well. Are we clear? Does anyone have a question here? Any question? Caristo, are we okay? Okay, so if you have got any question from your past papers, if you've checked, please, you can read it out, we solve it. I hope you people are familiar with your papers because yes, go on. Yes, modulus of x squared. Hmm. 5x plus 4 minus 2. Okay, so sketch the graph of this function. All right, nice. Now remember, when you are sketching modulus functions, if you have got the absolute value of x to sketch this function, this one will just go like this. Okay, if you put a negative in front, it will go towards the negative values of x. Take note of that. So if I add or subtract a constant inside, I'm going to equate this to 0. X minus 2 is equal to 0. I find that x is equal to positive 2. Mean that for this function, it will start at positive 2. But remember, x is what? Not x. The number in front here is positive, meaning that the function is going to be going up from 2. Okay? If there was a negative here, meaning that the function would be going down like that. Okay? So if the same function. Now let's say we have got absolute value, and then you have got, let me put a negative here, x minus plus 2, and then you have got a minus 3. How do you sketch this? Just equate what is inside here to 0. We're going to find x being negative 2, meaning that the function is going to start at negative 2. Okay, this constant you add here shifts the graph, so the graph is going to change and is going to go at what? At negative 2. So it's going to go at, at negative 3 in the y direction, so it will start from here. So this is where the function is going to start at negative 2 comma 3. The negative 2 came from you equating this to 0, and then the negative 3 has come from this one. Okay, and then look at the sign in front of the modulus is negative, meaning that the function is going to be going down. So that's how you sketch. So any constant that is added outside the modulus means that the function that is going to lift the function. All right. So expect this absolute value function, this negative 2 we are saying, for it to be shifted in the y to negative 2. Now first thing first, what you have inside here is a quadratic. You need to find the turning point and also the intercepts. So to find the turning point, just complete the squares. So I'm going to get the x squared plus 5x plus 4. We complete the squares. Now we need to make sure that there's a 1 in front here, and for real there's already a 1 there. So what I'm going to do, I'm just going to write x. Okay, now not x squared, just x, and I'm putting this in brackets. And then I'll look at the number that contains an x, that is a 5x. So the number in front of x, that's a 5. I find its half. So what's the half of 5? Who can tell us what's the half of 5?
5/2.
5 over 2. Okay, write it as a fraction, not as a decimal. 5 over 2. Don't put x. Square that. And then always subtract. Minus. This same number that you've written here, square it. 5 over 2 squared, that is going to give you 25 over 4. So this part you are able to see is the same as this part you are able to see here. And then I write now the 4 at the end, plus 4. So this is going to be the same as x plus 5 over 2 squared. Now 4, since we have got 4 in the denominator, and we know that 4 is the same as 4 over 1. So I multiply on top by 4, even down by 4. The aim is just to make the denominators the same. So I'm going to have 4 times 4, which is 16. So negative 25 plus 16. What do you get? Any quick mathematician, what do we get here? Is it a negative 9 over 4?
Yeah, -9.
Okay, so meaning that the turning point for this graph, the turning point, look at this value here, change its sign. So it will be negative 5 over 2, comma, this is going to be the y value. Don't change its sign, the same way it is, negative 9 over 4. If you want to find the turning point, say x is equal to negative b over 2a. This is negative, this is the b, negative b over 2a. A is the number in front of x squared. And then to find the y value, y is 4ac minus b squared over 4a. Now that's even much long because completing the squares is the shortest. Okay, so that's the turning point. Now again, I need to find the x-intercepts, where the graph is going to be cutting the x-axis. And how do you do that? You are going to equate this thing you have found to 0. So equate it to 0. I'm going to take this term the other side of the equation. So it will become positive 9 over 4. And that is going to be equal to the same x plus 5 over 2 squared. To do away with the square, I'm going to square root both sides. So what are we going to have? We are going to have x plus 5 over 2 being equal to square root of 9 is 3, square root of 4 is 2. Or I'm going to again write x plus 5 over 2 being equal to square root of 9 negative 3 over 2. Like when you take a square root of a number, it's going to be either negative or positive. That's why I've written positive and then negative. I'll now take the 5 over to the other side of the equation. So it will be x is equal to 3 over 2 minus 5 over 2, or x is going to be equal to negative 3 over 2 minus 5 over 2. So this will give us x being equal to, since the denominators are the same, I'll just say 3 minus 5. That's a negative 2. Negative 2 over 2 to be negative 1. Or x is going to be equal to negative 3 minus 5, that's negative 8, right? Negative 3 minus 5 is negative 8. The denominator is 2, negative 8 over 2, that will give us a negative 4. So that these are the x-intercepts. So I'll now remove this. We can now sketch the graph. Yes, Caristo?
Okay, like just to solve that one using factorize or even quadratic after finding the turning point.
Yes,
So you continue the formula.
you are able to do that. Okay, so that is x and that is y. Now remember this function has been shifted to what? To negative 2. Negative 2 there. Okay? And then whatsoever that you found, meaning that instead of your function, think of this, your function was supposed to cut the intercepts at 0. Okay, it's no longer at 0. It will cut at negative 2. Meaning that when x is equal to negative, this x being negative 1, it will be at negative 2. Okay, negative 1 is here, so we're going to have it. X intercepts means it was supposed to cut like here pa negative 1 na pashan, even at negative 4, negative 1 and negative 4. These are the x intercepts we have calculated. Now the function has been shifted negative 2 units down, meaning that the graph is going to come here, okay, at negative 1 there and negative 2 here. That's the negative 2 you're able to see here. So they've been shifted down. Now the turning point for this graph, you can see it is at what? It is at negative 5 over 2. What's negative 5 over 2? That's the x value. Negative 5 over 2 is just like 2 can go into negative 5 two times, remainder 1.5. That's negative 2.5. It is going to be somewhere here on the middle, somewhere there. And then the y value is negative 9 over 4, and that's just about negative 2 1 over 4, a number just a little above negative 2. So this is where the turning point is supposed to be, here. So since this is how the function is supposed to move, like this, it was supposed to be going like that and like this. I hope you're able to see that. Now this is absolute. Absolute means we don't want anything to do with negative values. Okay, don't want anything to do with the negative values. Then what are we going to do? We are going to reflect the part that is in the absolute to the upper part. The part that is in the absolute to the upper part. Please, you only reflect the one in the absolute. Yes, Richard.
Yeah, so this positive 4 in the absolute does not count here.
Which post? This one?
Yes.
So this one you take it as like this is as 1. So the function itself is supposed to be reflected. So the function is supposed to be reflected instead of you seeing this portion, you're seeing this portion that is on the negative y-axis. The whole of this was supposed to be shifted up. Like you don't want to see anything negative. Like anything negative, no. Now, that is how it was supposed to be, but it is going to change for this one. Why? Because already the function itself is telling you that you are starting at negative 2. Okay? Meaning that at negative 2 you are going to be allowed. So meaning that it's more like this is your new x-axis where negative 2 is. This is your new x-axis. Like that. So meaning that everything that is below here is what has to be shifted up. So what has to be shifted is just a turning point. Okay, instead of you having this negative 9 over 4, we're going to have positive 9 over 4. Positive 9 over 4. And 9 over 4 is just about, what's that value? It's just 2 1 over 4. So you got positive 2 here. So it will be slightly above. So this is where the turning point has been shifted. So remember the graph was supposed to be moving like this. going to the turning point, but instead of you crossing down, you're not going to go there. Okay, you're not going to go there. And then also this side, it is supposed to be going like that, something like that. Now instead of you coming to 10 here, you will not 10 there because you would have violated the absolute. So we're going to turn it to go to the positive, so that it is going to go like that, goes and touches the turning point and then comes back like this. So you see now the negative 2 has affected. The negative 2 has shifted the graph down because it was supposed to happen on the x-axis. This graph turning up like that is supposed to happen on the x-axis, but because of the negative 2, it has happened at negative 2 turning directions. So this is it, this graph.